So we've got this infinite series here, and let's see, it looks like a geometric series. When you go from this first term to the second term, we are multiplying by -3. And then to go to the next term, we're going to multiply by -3 again. So it looks like we have a common ratio of -3. So we could actually rewrite this series as being equal to -0.5, I could say, times -3 to the 0 power. -3 to the 0 power plus -0, or maybe I could just keep writing it this way, minus 0.5 times -3 to the first power times -3 to the first power minus 0.5 times -3 to the second power, -3 to the second power. And we're just going to keep going like that. And we could just say we're just going to keep having minus 0.5 times -3 to each, or to higher and higher and higher powers. Or we could write this in sigma notation. This is equal to the same thing as the sum from, let's say, n equals 0 to infinity. We're just going to keep going on and on forever. And it's going to be this first, it's going to be, you could kind of think the thing we're multiplying by -3 to some power. So it's going to be negative 0.5. Actually, let me just do that yellow color. So it's going to be negative 0.5 times -3, let me do that blue color. So times -3 to the nth power. Here, this is when n is 0. Here's n is 1. Here is n is equal to 2. So we've been able to rewrite this in different ways, but let's actually see if we can evaluate this. And so we have a common ratio of -3. So our r here is -3. And the first thing that you should think about is, well, in order for this to converge, our common ratio, the magnitude of the common ratio, or the absolute value of the common ratio, needs to be less than 1 for convergence. And what is the absolute value of -3? Well, the absolute value of -3 is equal to 3, which is definitely not less than 1. So this thing will not converge. This thing will not converge. And even if you look at this, it makes sense because the magnitudes of each of these terms are getting larger and larger and larger. We're flipping between adding and subtracting, but we're adding and subtracting larger and larger and larger and larger and larger values. Intuitively, when things converge, you're kind of, each successive term tends to get diminishingly small, or maybe it cancels out in some type of an interesting way. But because the absolute value of the common ratio is greater than or equal to 1 in this situation, this is not going to converge to a value.